ጋይስ በሌላ ፕሮብለም ተመልሻለሁ። በዚህ ፕሮብለም ላይ የምንመለከተው ፕሪቪየስሊ ካየነው ፕሮብለም ጋር የተወሰነ የተመሳሰለ ነገር ነው። ምናልባት ኮንሰፕቹዋል ሊመስል የሚመስል ጥያቄ ነው የምንመለከተው። ወደ ፕሮብለሙ ስንገባ a spring is cut into three equal parts. If its original force constant was k, what is the force constant of each new spring? So ምንድነው ዲማንድ ያደረገን ከዚህ ጥያቄ? We have seen previously the combination of springs in series and parallel. As a result of that, the effective spring constant also calculated using a relation of combinations such as inverse spring constant summation and direct summation. So here it demands, here we have a spring whose spring constant is k. Now what will happen if we cut this spring into three parts? So you would get a spring, a little minute springs having a spring constant of, let's say, k1, k2 and k3. So equal lengths ነው የተቆረጡት ስፕሪንጎቻችን። So በእኩል lengths cut ከተደረጉ one can find simply that k1 equals k2 equals k3. So let's say this thing gives us a k prime, a spring constant which is equivalent to for all of them. Now the question is simply to find the spring constant k1, k2, k3. So ይህንን ፕሮብለም ወዴት መቀየር እንችላለን? Here እነዚህ ሶስቱም ስፕሪንጎቹ we can assume them as a series connected springs. So when they are connected in series connection, the effective spring constant whose k is simply given by the relation 1 over k equals 1 over k1 plus 1 over k2 plus 1 over k3. We have seen previously ከዚህ ቪዲዮ ቀደም ያለው ቪዲዮ ላይ አይተናል. So it would be easy to find effective a new spring constant k prime. So this is reduced into this relation 1 over k equals 1 over k prime plus 1 over k prime plus 1 over k prime. In fact, one can find from this relation 1 over k is simply 3 over k prime. Now, simple simplification, k prime would be k over 3. Sorry, not k over 3, it is 3 times the spring constant k, where this k is spring constant of the combined spring or effective spring constant of these three springs. So this effective ጥያቄው ዲማንድ የሚያደርገው in terms of effective spring constant or original spring constant እንዲገልጽ ነው. So therefore k1 equals k2 equals k3. Those are those springs have equal spring constant, therefore the spring constant would be 3 times the original spring constant, or generally it would be a higher spring constant from the original spring. So generally if we divide a spring whose spring constant is k into n equal pieces, Okay, n equal no n equal springs ምን ማለት እንችላለን? የእያንዳንዱ spring constant would be the sum of, so 1 over k in that case would be, let's simply draw in. So you might have generally a spring whose spring constant k. So ይሄንን spring ለn የተለያዩ ቦታዎች ላይ ብንከፍለው so የእያንዳንዱ minute spring የሚኖረው constant would be simply from previous relation 1 over k equals 1 over k1 plus 1 over k2 plus up to 1 over plus 1 over kn. So n number of spring are ብናስብ ማለት ነው። since እያንዳንዱ spring constant እኩል ስለሆነ so 1 over k it could be n times, let's say, k prime. So k prime would be the spring constant of individual springs. This implies the spring constant of individual spring would be n times the original spring. So this is a general case. Previously specific case, if we divide into 3, the spring constant would be this thing, n would be 3. So it will go on like this way. So spring constant would be increased if you simply divide into 2. But if you simply add the springs one to another, the spring constant also decrease. This is the relation that you need to know in relation to the previous problem. So I'll see you on the next problem. Bye bye.